All right, so let's continue to talk about section 4.3, and now let's look at example 9. Okay, so find the general solution of the equation. So here we should use integrating factor. Okay, integrating factor, okay, multiplying integrating factor. But however, before we find the integrating factor, so firstly we should simplify the equation to be the standard pattern, which is dy by dx plus p of x times y equals qx. Okay, so it means that we should divide cosine x on both sides, so it becomes dy by dx plus 2 sine over cosine will be tangent x times y equals cosine x to the power of 3. And then we know p of x will be 2 tangent x. So the integrating factor is e to the power of the integral of 2 tangent x dx, okay, the integral of 2 tangent x. So let's try to find the indefinite integral. So e to the power of, so tangent x can be written as sine x over cosine x dx, okay, and then we can use integration by substitution. Actually, we can write sine, we can move sine into d, and which becomes d negative cosine x. Okay, so d negative cosine x will be sine x. Okay, so it means that it becomes e to the power of negative 2 and then 1 over cosine x d cosine x, and it will be e to the power of negative 2 and ln absolute value of cosine x. Okay, and it will be e to the power of ln and cosine x to the power of negative 2. Okay, so it is square, so we can remove the absolute value side, and finally this becomes cosine x to the power of negative 2. Okay, so which is secant x squared. Okay, and pay attention. Okay, you should know e to the power of ln f of x equals f of x. You should know this property, and also, or maybe a to the power of log a f of x equals fx, and also log a to the power of fx equals fx. Okay, pay attention to the results here. Okay, the property. And so we find the integrating factor, and then we multiply the integrating factor on both sides of the equation. Okay, so we multiply secant x squared. So secant x squared dy by dx plus 2 tangent x secant x squared times y equals cosine x cubed times secant x squared, which is cosine x only. Okay, it becomes cosine x only. And now after multiplying the integrating factor, so the left hand side can be written as the derivative of a product, so which is d, the two functions should be, one is y, another one is secant x squared. So it will be y times secant x squared by dx. Okay, and you may check. So firstly we dy and keep secant, okay, and then keep y d secant will be 2 secant will be 2 secant x, and then d secant again it will be tangent x secant x. Okay, so becomes 2 tangent x secant x squared. Okay, so it is correct. So now we can multiply dx on both sides. It will be dy times secant x squared equals cosine x dx, and do integration. And left hand side is y secant x squared. Right hand side it is sine, okay, because the primitive function of cosine is sine, okay, and then plus constant c. So finally we divide secant x squared. It means we multiply cosine x squared. Okay, we multiply cosine x squared. So which is y equals sine x, or maybe sine x plus constant c multiplied by cosine x squared. Okay, so this is example 9. Okay, example 9. And now let's do some practice. Okay, so exercise 4c. So before you do this question, you may check whether we can use the previous two types, separating variables method, or maybe the second type, which is that the one side can be written as a derivative of a product. So for this question, obviously we cannot write the left hand side to be the derivative of a product. Okay, so we may use integrating factor. Okay, so firstly you should identify. So this equation follow the standard form. So dy by dx equal plus px times y equals qx. Okay, so here we know px here is 2. So the integrating factor is e to the power of the integral of 2, which is e to the power of 2x. Okay, so here pay attention, we don't plus constant c. Okay, we don't need to plus constant c. And then sorry, some problem. Okay, so and then we will multiply e to the power of x on both sides, so which will be e to the power of 2x and times dy by dx plus 2 e to the power of 2x y equals e to the power of 3x. Okay, e to the power of 3x. And then now let's check whether the left hand side can be written as the derivative of product. And of course yes, so the two functions should be e to the power of 2x and times y. Okay, so by dx equals e to the power of 3x, and then it will be e to the power of 2x d e to the power of 2x equals e to the power of 3x dx. Okay, and then we continue to do it. So here we can so we can integrate both sides. So we can get the answer. So left hand side just e to the power of 2x times y, and the right hand side is it must have e to the power of 3x, but we have to multiply 1 over 3 to adjust it. Okay, so this is the answer. And finally, we divide e to the power of 2x on both sides. It will be, okay, it will be y equals 1 over 3 e to the power of x plus c e to the power of negative 2x. Okay, so this is the final answer of question 1. Okay, question 1. And now let's look at question 5. Okay, question 5. So question 5, the left hand side. So left hand side, you see, or maybe the left hand side cannot be written as the derivative of a product. So we have to find an integrating factor, okay, and also it follows the type dy by dx plus p of x y equals qx, okay. So now px just equals tangent x. So the integrating factor is e to the power of the integral of tangent x. So just now we know the integral of tangent x. Okay, so actually here it is ln absolute value of negative cosine x. Okay, and then or maybe I show the full steps. Okay, I show the full steps. So it equals e to the power of sine x over cosine x dx, and it equals e to the power of negative 1 over cosine x d cosine x. Okay, so finally it will be e to the power of ln absolute value of cosine x, which is e to the power of ln absolute value of cosine x to the power of negative 1. Okay, to the power of negative 1, and we should give a bracket to it, and then it will be 1 over absolute value of cosine x. Okay, so actually 1 over absolute value of cosine x can be 1 over cosine x, or maybe negative 1 over cosine x, depends on cosine x is positive or maybe cosine x is negative. Okay, however, as we know, for the integrating factor we may just choose the positive one. Okay, so choose the positive one, so it means that the integrating factor, it can be 1 over cosine x. Okay, so now we multiply cosine x on both sides, so it will be, so we can get 1 over cosine, or maybe cosine x, 1 over cosine x. Actually it can be written as secant. Okay, so I multiply secant now. Okay, so secant x dy by dx plus y tangent x secant x equals secant x times cosine x, it will be x only. Okay, so the next step, so the left hand side can be regarded as the product of two functions, which is the derivative, okay, of the product of two functions, which is y and secant x, and then write it as dy times secant x equals x times dx, and then do integration. And finally, the left-hand side is y times secant x equals 1 over 2x squared, and then plus constant c, okay? And finally, we multiply cosine, okay? We multiply cosine x, okay? So finally, the answer will be y equals 1 over 2 x squared cosine x plus c times cosine x, okay? So this is the answer of question 5, okay? And then let's look at question 7. Question 7. So for question 7, firstly, you see that this equation is not in the standard form of the third type, okay? So firstly, we divide x squared on both sides first, so it will be dy by dx, and then minus y over x equals x over x plus 2, okay? And then we know px just negative 1 over x, right? And then the integrating factor is e to the power of the integral of negative 1 over x, and which will be e to the power of negative, okay, negative ln, okay, negative ln absolute value, okay, ln absolute value of x, okay? So it can be written as e to the power of ln 1 over absolute value of x. So finally, it will be 1 over absolute value of x, okay, absolute value of x. So actually, 1 over absolute value of x can be, okay, can be 1 over x or maybe negative 1 over x, okay? So when x for x is greater than 0, for x is smaller than 0, but no matter how, okay, no matter how, it is because we multiply, if we multiply 1 over x, if we multiply 1 over x on both sides, so of course it is very simple, but if you multiply negative 1 over x on both sides, so we can actually we can cancel negative 1 for each term, okay? So it is also 1 over x also, okay? So here we choose, okay? So choose integrating, okay? Choose, so choose 1 over x as the integrating factor, okay, integrating factor. So we can have 1 over x times dy by dx minus y over x squared equals 1 over x plus 2, okay? And now the left-hand side must be written as the derivative of a product, okay? So let's see. So it will the two functions should be 1 over x times y. All right, so you can check dy and keep 1 over x true, okay? And then d1 over x should be negative 1 over x squared, okay? So it is true also. So our calculation is correct. And after that, it can be written as and we do integration. And finally, the left-hand side is y over x, and right-hand side is just ln absolute value of x plus 2 plus constant c. And because x is greater than negative 2, as you see, okay, x is greater than negative 2, so we can remove the absolute sign. So y over x equals ln x plus 2 plus constant c. And finally, y just equals x times ln x plus 2 plus c times x. Okay, so this is question 7. Okay, question 7.